Hey everyone. In this lecture, we're going to be covering counting, product, and sum rule, right? So by now we have covered sequences. We covered it in the beginning. Then we went down to summations, and then we covered sequences. Sorry, I should say recurrence relation, right? So you've covered a lot of stuff by now, and it is getting super complicated. But once again, we are starting with like a simpler topic, I should say, which is going to be combinatorics, right? So one word is we call it counting, and the other word is we call it combinatorics. Okay, so what is it again? Combinatorics is the study of counting objects with certain properties, right? I'll try to explain it in very simple words. The point is we are trying to figure out how many ways can we arrange something, or how many ways can we count something, right? This will all make sense when we look at a lot of examples later in the section and in the other videos. But for now, it's pretty much we are trying to figure out how many possibilities are there, right? And the way we figure it out is by kind of like finding some formulas or by multiplying numbers, and it's pretty much like that, right? Okay, so it is the study of counting objects with certain properties. So the big question is how many ways can we, right? So how many Ks can we do something, or how many ways can we, let's say, make a password, or how many ways can we make a number plate, stuff like that, right? Okay, so what are the real world applications and why do we need to understand it? Once again, it is because of passwords, right? License plates are one of the biggest examples, and then another very big application is cryptography, right? Think about passwords, right? Let's just take the password example for once. Passwords today need to be huge, right? Why? Because if you have a very small password, it could be easy for some hacker to guess. Let's say I made a password which is, um, let's say I made a password which is just 2 characters, right? And if it's 2 numbers, it could be very easily guessed by someone. A hacker could like open my computer, or like they can try to access my one of my accounts or something, and then they could try to guess it. If you go to any website today, they usually like have this kind of a requirement that your password should be like strong or like high, and they kind of ask you to use a combination of letters, capital, small letters, or some numbers, right? And the reason why they do it is so that it becomes more and more difficult for somebody to guess your password, right? I'll try to make it like this will all make sense more in the future, but for now, just try to think of a simple example, right? Let's say you make a password of 2 numbers, and it is only you're only using numbers, right? Meaning you could use, let's say you can only use the number 0 to 9, right? Now think about this, right? I made a password and I asked my friend to try to guess the password, right? Or try to figure out my password, try to break my account. All they have to do is they have to do like write a for loop, and they have to go from 0 to 99 numbers and then feed it into my system, right? They just have to try it. It is very easy. That for loop is going to take like almost like less than 1 second, and they would be able to find what the correct password is, right? It's that easy. But now think about if I kind of, let's say I have 4 digits now. Now 4 digits makes it more difficult, right? It now the number of the possibilities has increased a lot. So the entire point of making password comes down to having multiple, first of all, having multiple combinations of numbers, letters, capital letters, small letters, on and maybe special characters too. Along with that, having a very long password. So what that does in very simple words is there are like a lot of possibility of numbers. If I have 4 characters, if I have 4 digit number password, then it would go from 0 to 9999, right? I would have to try all these values. When I had just 2, I just had to try 0 to 9. But now if think about if I had letters plus special characters too, that increases the possibility of the password to a lot, right? Making it extremely difficult for somebody to guess the password. Okay, so that was about passwords. License plates. Think about license plate, right? Now, there are so many people in the world, and you can't, so every country and every place, they define a number plate based on what the state is, and then they have to figure out what the number plate should be, right? So that's kind of another property of how many possibilities of number plates could exist, right? And the third one is cryptography, which is like more difficult to understand, but we will try to see if we can cover it in the future lectures. Okay, so few examples I've given over here. How many 4 digit pins exist, right? So just once again, this is like one of the examples of how many 4 digit pins exist, right? I'll not give the solution over here, but we will cover this in the next lecture, or I should say in the next part. So it will all start making sense, right? Okay. Next one is how many ways to seat 5 people? Like how many ways can you arrange 5 people? And how many 8-character passwords with a digit are possible, right? These are just some of the examples. One more thing that I wanted to explain is it is the study of counting objects with certain properties. The word properties over here pretty much means like this, right? Like it is a 4-digit password. How do we arrange people? Or we are trying to make a password of 8 characters with a digit, right? These are some of the examples of the possible properties that we are talking about. Okay, so that's pretty much it. Now let's move on to the next topic, which is going to be the product rule. Okay, let's try to understand the product rule and some of the examples, right? This is going to be super important and it's going to be very easy to understand. So I'll try to make it as simple as possible. Okay, so if a task has 2 steps such that step 1 can be done in n1 ways, n1 is just like the count. So let's say n1 is the count of number of ways you can do it, represented by n1. Step 2 can be done in n2 ways. The total ways that you can do the task is going to be what, right? So I'm asking you a simple question, right? I say I'm giving you a task, right? And it has 2 steps, right? You can do step 1 in this amount of ways, right? I give you this many options, like you can have, let's say, 10 ways to do this certain task. I don't mind it. And you can do step 2 in n2 ways, like let's say 5 ways or maybe 6 ways, right? But one clarity that I give you is that you need to do both steps. You need to do step 1 first, and then you need to do step 2 as well. But you have the option to do it in different amount of ways or some count of ways, right? So now I ask you the question, so how many total ways would you have, right? You can try to pause the video and then try to figure it out. Okay, so if you were able to figure it out, that's fine. But before I give the answer, let's take a look at this example first, right? You have 4 shirts, 3 pants, and 2 pairs of shoes. How many outfits can I make from this, right? I think this question seems a lot more easier to understand, right? I have 4 shirts, I have 3 pairs of pants, 2 pairs of shoes. So the way I can count the number of outfits I would have is I have 4 shirts. So let's say if I can pick the first shirt, combine it with the first pant and the first pair of shoes, or maybe what I can do is I can pick up the second shirt with the first pair of pants and then combine it with the second pair of shoes. So think about this, right? This way I can have so many combinations. But if I ask you the question, how many combinations would be there in total? So I can say I have 4 shirts. Now try to take a look, like carefully look at the board, right? I say I have 4 shirts, right? I can combine it with 3 pants. So that would give me 4 multiplied by 3 combinations, right? And then I can combine it with further with 2 pairs of shoes. So this gives me 4 threes to 12, 12 to the 24 combinations. Okay, so let me just try to explain it one more time, right? I'm saying I have 4 shirts, 3 pants, and 2 pairs. I can pair first shirt with the second pair of pants and the second pairs of shoes, or I can maybe pair the first shirt with the first pair of pants and the first pair of shoes. So if I try to figure it out, it's basically just multiplication, right? I have 4 ways of 4 shirts. If I multiply it by the number of combinations of the pants I have, that is 3, giving me 12 combinations. But then I can also choose 12 multiplied by 2, 24, because I also have 2 pairs of shoes, right? Giving me in total 24 combinations. So now let's get back to this problem, right? If a task has 2 steps, such that step 1 can be done in n1 ways and step 2 can be done in n2 ways, right? So let's just say n1 is 10. Let's just assume for now it's 10, and let's say n2 is 5. So I say, okay, you have 10 ways you can do the step 1. You have 5 ways you can do step 2. So how many combinations would be there? What would be the total number of count? If you think about it, it would simply be 10 multiplied by 5, which is equal to 50 ways, right? So I'm saying if n1 was 10, n2 was 5, you would have 50 different combinations or 50 different ways of doing this task, right? But now, let's say, instead of 10 and 5, let's say I had 20 n1 and then 20 n2. So in this case, I would have 20 multiplied by 20 ways, which would be 400. So the answer to this question, right, if you have n1 ways and n2 ways to step 2, and we need to do both steps, right? That's the important part of this question. That's the important part of the product rule. So if I have n1 and I also have to do n2, so I would have, I should say, n1 multiplied by n2, and that would be my product rule, right? Okay, so I hope you guys are able to understand what exactly we did, right? It's pretty much basic multiplication. If you logically think about it, just like I explained it with this example, right? It's pretty much we are making the combinations. In this example, in this task, right, I was supposed to do step 1 in n ways. I had the options, and task 2, like step 2 in n2 ways. So total number of ways would be n1 multiplied by n2, and that exactly is the product rule, right? Okay, let's look at another example. Let's look at the example of, let's say I need to make a password of 4 pins. So let's say I ask you the question, right? Make a password of 4 digits. How many uh, possible passwords would be there? So let's say this is just like the representing the 4 digits. The possibilities are 0 to 9. So my question is, you can use 0 to 9, right? You can use 0, 1, 2, 3. You have 10 numbers, and you need to make a password of 4 digits, right? Now my question is, how many total possibilities of passwords would there be? Right? Now just try to think about how you did example 1 and how we figured out this task and the product rule, and then try to relate it to this question, right? You can try to pause the video and try to figure out. Okay, so if you think about this, right, first of all, I can choose 0 to 9, meaning I have 10 numbers, right? I have 10 numbers, 0 to 9. So every single place could have 10 possibilities. I can say that. In the first place, I could have 0, or it could be, I could have maybe 0, right? I could have maybe 0, 1, 1, 1. Or maybe in the third place, I could have 2. Maybe in the second place, I could have 3. But the important point is that every single place, every single of these digits, right, there are 10 possibilities. So how many total number of passwords would there be? I can say 10 for the first place, 10 possibilities for the second, 10 for the third, and 10 for the fourth. How do I find out the total number of possibilities? Simply, if you relate it to this rule, it would be 10 multiplied by 10, multiplied by 10, and multiplied by 10, which gives you 10,000 possibilities. Okay, so I hope this is kind of making sense. You can also kind of think of it like this way, right? It's like step 1 can be done 10 ways. Step 2 can be done 10 ways. Step 3 can be done 10 ways, and step 4 can be done 10 ways. So combining it, how you do it would be using the product rule. So you just multiply all of them together, giving you 10,000 possible ways, right? So I hope this is kind of making sense. So in total, you would have 10,000 pins possible, right? Okay, now let's look at the final example, right? How many 3-letter strings from the set A, B, C, D with no repeated letters? Okay, so let's try to look at this question. I'll try to explain the question first. I'm saying how many 3-letter strings from A, B, C, D with no repeated letters. I'm asking you to make a string of only 3 letters. I'm giving you the option to choose any of these, right? A, B, C, D, E. You can choose any of them. You need to make a string of 3 letters. And my question and my property is that you cannot repeat repeat any of the letters. Meaning you can't do A like B, B, A. You cannot do it, or you can do C, D, D, this is not possible, right? You cannot repeat a letter. That's very important. Okay, so how many total possibilities would be there? Let's try to understand this question, right? Okay, so if you look at this, right, I have 5 total number of possibilities in the first step. So first of all, I need to make a 3-digit string. 3-digit string is what I'm trying to make. Think about how many possibilities are there in the first step, right? In the first step, I could choose any one of these values. I can choose A, B, C, D, E, which means I have total 5 possible values I can choose. So that means I can choose 5 for the first one. Okay, now think about how many possibilities would you have for the second one. Okay, so for the second one, you would have 4 possibilities. Why? Because think about this, right? In the question, they're saying you cannot repeat the letters, right? So that means if I, let's say, used A in the first time, for the second time, I would only have B, C, D as the options. If I used B in the second time, I would have only C, D, E as one of the options that I could choose. So I cannot repeat any letters. So for the first time, I would have 5 possibilities I can choose from. Second time, I have already used a letter, so I cannot use it again. That means I have only 4 possibilities. And if you think about it, in the third time, I would have 3. So using the product rule, then how many total letters, 3-letter strings would be there? It would be 5 multiplied by 4 multiplied by 3. So that would be 60. Okay, so I hope you were able to understand the product rule. And this is not like very complicated. You can try to think of it in a very logical way. It's just pretty much multiplication of stuff, right? So the more and more examples we solve, we'll take a look at some practice problems too. The better you will get at understanding this. But I hope this is making sense until this point, right? Okay, now let's move on to the sum rule. Okay, so now let's try to understand the sum rule, right? This is going to be once again very easy to understand. So now in this case, I've been given if a task can be done either way 1, where you have n1 options, or way 2, and the options don't overlap, then what would be the total number of ways? Let me just try to explain it in simple ways, right? So I give you a task. I say you have 2 ways, and both of those ways further have multiple options, right? So way 1, you have n1 options to do it in that way, and in way 2, you have n2 options. So I ask you that you have to pick either one of these ways, right? You can't pick both. If you remember in the last time, right, in the product rule, I told you that you have step 1 where you have to do step 1 in n1 ways. You have n1 ways to do it. And after that, you also have to do step 2 where you have n2 number of ways. In this case, I tell you, you have to only pick one. You either pick way 1 or way 2. Way 1 you can do in n1 options, and way 2 you have n2 options. So what would be the total number of ways? So just try to pause the video and then try to think about what this would be. So this would simply be n1 plus n2, right? Very simple to understand, right? And the reason why we are doing a plus in this case, when instead in the product rule we did the star, or I should say multiply, is because in this case I am supposed to pick either. I'm not doing both the steps in this case, right? I'm not doing step way 1 and then way 2 after that. I'm supposed to do plus, meaning I'm supposed to pick either of them. I think this will make more sense with this example, right? So a class offers 15 individual projects or 8 group projects, and you need to pick one. So what would be the total number of choices you have? Think about this, right? Let's say you're working in a class. Your professor offers you can either choose one of the 15 individual projects, right? If you're working alone, or if you're working in a group, you can pick one of the 8 group projects, but you cannot pick both. So in that case, you would have 15 plus 8 number of options, right? Meaning it's just going to be 15 plus 8, right? Why? Because you have to pick either. You're not picking both the group project and the individual projects, right? So that is exactly why this is called the sum rule, right? You're picking one of the things. Now, let me try to explain like the difference between both the product and the sum rule, right? So I'm going to use this area over here. Okay. Okay. So the idea is going to be very simple, right? In product, we are pretty much doing and versus or. So think about this, right? Think about one of the examples. Pick shirt and pant. Pick shirt or pant. Okay. So let's try to understand the product rule and what is the difference in the product and the sum rule, right? It's pretty much the differences and the usage of and versus or. So when I say you have to do step one and step two, where step one can be done n one way, amount of ways and step two can be done n2 number of ways, then you are doing multiplication. So whenever you are kind of seeing and being used, that means you're supposed to use multiplication, right? When you see or, meaning you're supposed to pick either one of these, right? In that case, you're supposed to use addition. So one of the examples is, let's say I say pick a shirt and a pant, right? In this case, you're supposed to pick a shirt and a pant, right? So let's say you have 4 shirts and 3 pants. That means you would have 4 multiplied by 3 amount of ways to pick options, right? Okay, but in the next case, let's say I'm asking you pick a shirt or a pant. So let's say you have 4 shirts. You're going to, let's say, a market and you see 4 shirts. Like you can either buy 4 shirts or you can buy 3 pants, right? In that case, you would not be multiplying it. In that case, you would have, okay, I can either pick 4 shirts, meaning 4 options plus 3, which is going to be the number of pants, right? So in this case, it would be n1 multiplied by n2, and in this case would be n1 plus n2, right? So I'm just trying to explain it again and again, so it kind of like becomes very clear in your mind, and so that you just kind of get the idea again and again, right? So I hope you were able to understand this example. Now let's move on to the next topic. Okay, everyone. So now let's look at one of the examples, right? Now this is going to be a very tricky question, to be honest, but I'll try to make it as easy as possible, right? Okay. Combining both rules. So we're basically combining both rules we covered, right? Once again, we covered the product rule and the sum rule. In the product rule, you would be asked, asked in a question, and the question is using and. So step one and step two you're supposed to do. That means in that case you're supposed to use multiplication. And the second case is if they're saying you have to choose either of these things. So either you can choose, let's say, 4 shirts, or you can choose 3 options of pants. Then in total you would have 4 plus 3, right? That would be the sum rule. Okay. In this question, we're going to be combining both. So first, I'll try to explain the question to you guys. I want you guys to pause the video and then try to solve it. Okay. So a password is 6 characters long, right? At each position, you can have a letter or a digit, right? Let's just try to understand this part. So I'm just going to try to draw like what the password would look like, right? Okay, so the password is 6 digits. So 1, 2, 3, 4, 5, 6, right? Okay, so at each position, you can have either the letter or a digit. So once again, I have a or over here. Or would basically mean, that means we're not multiplying. In this case, I have to add the number of options I have, right? So number of options equal 26 plus 10, right? This much I think you guys can understand on your own. But the complete password, now this is the most important part, right? The complete password must have at least 1 digit. So the question is saying, okay, so you have to make a 6-digit password. At one place, you can either have a letter. So we have 26 letters, right? A to Z. And or you can use a digit, right? Digit meaning 0 to 9, you can use any of the digits. So in total, at one position, you have 36 options. Okay. But now this is the interesting part, right? The complete password they're saying must have at least one digit, right? So I'll try to explain how do you solve this question. One way would be you try to find the password in the brute force way, meaning you just try to randomly figure out how would you like the number of passwords, right? One way could be it's saying at least one digit, right? That means the password would have at least one digit. So one is I can try to let's assume that okay, if the first place has digit, let's consider it has only one digit, right? If it has one digit, it could have a digit at the place one, maybe two, maybe three, maybe four, five, six, right? It could have any of them, so I would have to add all of those up together. Second is the password could have two digits because the question is saying we need to find the complete password and it must have the count we're talking about. It needs to have at least one digit, right? So it could be at least one, but it could be more. So the password could have two digits, three digits, and even it could be that all of them are basically digits, right? So maybe if it has only one digit, then it could be at the first position, second, third, fourth, fifth, sixth, maybe. If the password has two digits, then the amount of the count of passwords you have increases. And now think about if you have three digits in your password, then maybe the first two could be digits and the third one. So maybe the first two could be digits and maybe the fourth one is digit, right? So think the problem is that just trying to randomly and brute force finding the solution is like very, very difficult for this question, right? So the hint in this question is, okay, the question is saying the complete password must have at least one digit. So my hint is, okay, how about I try to find, first of all the possible passwords I can have. And then I subtract all the passwords that don't have any digit, right? Let me try to explain what I mean, right? The password can be can be separated into two different types. So if I have a password, one option is no digits. Second is at least one digit. What I'm trying to say is the passwords can be divided into two types, right? Which don't overlap. One is the type of passwords that have no digits at all, right? And the other part of it would be the passwords that have at least one digit. If we combine all these together, that would give us the total number of passwords that are possible in total, right? Okay, so you guys can try to pause the video and then try to understand what the solution would be. Okay, let me try to explain the answer now. Okay, so my idea for the question is, instead of me trying to brute force find like all the passwords that have at least one digit, I would, let's say if I'm doing it brute force, right, I would first say it has one digit, and then I would try to figure out all the passwords with one digit, the count of passwords, then try to find out all the passwords with two digits, then three, then four, then five, which is like a very tricky way. Instead, what I do is let's just try to first find all the possible passwords, right? No restrictions. So if I have all passwords So if you have no restrictions, right? Think about it. If you have no restrictions at one place, you could have 36 options. So if you have 36 options in one place and you have a 6-digit password, that means you would have 36 multiplied by 36. 36. 2, 3, 4, 5 multiplied by 36 equal 36 to the power 6. Okay, so this is the total number of passwords possible if you have no restrictions, right? Once again, because uh, at every single position you can have a letter, 26 letters plus a digit, so 36 total options. And the question is saying it is like a 6-digit password, or I should say a 6-character long password. So the total options would be 36 multiplied by 36 and 36 to the power 6, I should say, right? Okay, now instead of me trying to find all the passwords with at least one digit, how about I subtract the passwords with no digits from the total number of passwords, right? That would give me this part. Because think about this once again, right? Total number of passwords with no restrictions can be divided into two parts. One is the passwords that have no digit at all, and the other part would be the passwords that have at least one digit, right? So all I have to do is, it is easier for me to find the passwords that have no digits. And how do I do it? Right? Think about this, right? So if a password has no digit, then you would have 26 options for any one of these places. So it would be 26 to the power of 6, right? Because you have 6 positions. Okay, now all you have to do is, I need to just subtract this from 36 to the power of 6. And that would give me the passwords that have at least one digit, right? So I'm just going to do it over here. Passwords with at least one digit would be total which is equal to 36 to the power 6 minus 26 to the power 6. Now you don't have to find the exact value, but I think you can leave it at this point, right? So I hope you were able to understand this question. I'll just try to give a quick summary of the question, right? The password is 6 character long. The question was asking, at each position, it said you can have either a letter or a digit. So first thing is, I see a or, that means I'm supposed to use the sum rule, right? I can either use a letter or a digit, so I have 36 options in total. Second is, the question said the complete password must have at least one digit, right? So needs to have one digit. Now, instead of me trying to directly find at least one digit passwords in total, because that's like a more difficult problem to solve, what I do is I say, let me try to find all the count of total number of passwords, right? And that turned out to be 36 to the power 6 passwords, all passwords without any restrictions. Then what I did is I figured out that, okay, if what is the opposite of passwords with at least one digit? It would be passwords with no digits. So if I can subtract the passwords, the number of passwords with no digits from total number of passwords would give me exactly the count of passwords with at least one digit, right? And that exactly is the solution to our question. Okay, now I'll give a bunch of practice problems for you guys to solve, and then we will move on to the next lecture. Okay, everyone, I've given 2 questions on the board. I think they're easier questions. So take your time, try to pause the video and then solve these questions. Okay, so I hope you were able to solve these questions. Now I'll just give the solutions. First question is, how many 5-digit numbers have no repeated digits, right? But I've been given a condition, right? Now this is the important one. The first digit can't be 0. So let's just try to solve this question, right? I'm just going to use these like dashes to explain the question. So how many 5-digit numbers have no repeated digits? So the question is, I cannot repeat a digit, right? So let's say if I used 9 in my first position, I cannot use 9 again. So now let's think about this, right? First of all, the first digit can't be 0. So in total, you have 10 digits. So you can use 0 to 9 is 10 digits. But I can't use 0 in the first position. So I have 9 options for the first one. Okay, so now I used one digit, right? I have one option less. So think about how many options you would have for the second one. For the second position, you would have 9 again. Think about this, right? For the first position, we cannot use 0. So that leaves me, I can use 1 to 9. So 9 options in total, right? But I can use 0 in the second position, right? But in the second position, I would have already lost one of the digits. So let's say I used 1 in the first digit. Now in the second digit, I could use 0, 2, 3, 4, 5, 6 until 9. So 9 for the first position, 9 for the second. Now from the third one it would be 8, 7, 6. And what would be the total number of 5-digit numbers with no repeated digits? 9 multiplied by 9 multiplied by 8 multiplied by 7 multiplied by 6, right? And that would be your answer. Okay, second question. A restaurant has 6 appetizers, 4 mains, and 4 desserts on the menu. If you order the full meal, 1 appetizer and 1 main and 1 dessert, how many combos are possible? So this is going to be very easy answer, right? You can choose one of the appetizers. So let's say I choose the second appetizer, first main, second dessert, right? That's one of the combinations. Or it could be the fifth appetizer, the fourth main, fourth dessert. So in total, I would have 6 multiplied by 4 multiplied by 4 combos. And let's say if you just want one item from the menu, right? So you can choose from either 6 appetizers, or you can choose from the 4 mains, or you can choose from the 4 desserts. How many options you would have? It would be 6 plus 4 plus 4. So that would be 14. Okay. So I hope you were able to solve these questions, and I hope you were able to understand this lecture. Once again, if you guys have any suggestions or any improvements that I can make for me, leave it in the comments down for me. And if you guys can subscribe and share it with any of your friends, that would be really awesome. Okay, I'll see you guys in the next lecture.